Hey guys, how you're doing? So for today's videos, we are gonna solve the logistic equation, which out of equation of the form we have y prime equal to some function p of x times y minus a times y minus b. In order to solve them, I will have to assume that I am a little bit familiar with the concept of separable ODE, which is separable ordinary differential equation or simple differential equation as you prefer, and that you know a little bit about partial fraction. You will not really need to know everything about partial fraction. It's just gonna be easier if you already are familiar with them, but don't worry, I'm gonna get through all the calculation you need in this specific situation. So that's all for the introduction. Grab your pen and paper and I'm gonna meet you in a minute. So guys, we start with this lovely differential equation, which as we said is just a logistic equation. The first step in order to solve this kind of differential equation is just to rewrite our y prime as dy over dx. Indeed, as you can see, these guys is just a kind of separable variables. Indeed, we have the y prime on one side, and on the right hand side we have something depending on y times something depending on x that we think can just to be 1. So first step, we just rewrite y prime as dy over dx equal to y minus 2 times y plus 2. And then what we have to do, we're just to bring everything on y on the left hand side, and we left the dy there, and everything in dx on the right hand side. So we got dy over y minus 2 times y plus 2 equal to dx. And now, as easy as it can be, we have to integrate both sides. So we integrate. And now the right hand side is pretty easy. Indeed, we just get that the integral of dx is just equal to x plus c. Indeed, you can think that there is just a 1 here and apply the standard rule of integration. And now the harder part is the integral in y. Indeed, to solve this integral, we have to use the technique called as partial fraction expansion, partial fraction. Therefore, we have to start to look for something like this. First things first, we want to rewrite the fraction, which is 1 over y minus 2 times y plus 2, to be equal to a over y minus 2 plus b over y plus 2. And now I want to find these two constants, a and b, such that this equality holds. To do that, I have to sum now the two fractions on the right hand side. So on the left hand side, I keep the same things. And on the right hand side, I don't do any calculation. Just the denominator I know is just the product of the two denominator. And now I just cross multiply. So a times y plus 2 and b times y minus 2. And I write it as it is. I don't expand anything. So what do I get? Since these two fractions, they have to be the same, and they have the same denominator, they also need to have the same numerator. So I have just to impose that 1 has to be equal to a times y plus 2 plus b times y minus 2. And this has to be true for all y. And in particular, it means that it has to be true for some specific values of y. And the idea now is that we can pick specific values for our variable y, so that this expression becomes particularly simple and we can then obtain a and b. For instance, a particularly simple value for evaluate the right-hand side expression is when y exactly equal to 2. Why is that? Because now this coefficient become exactly 0. So it disappears. And I will get an expression involving only a. Let's go through this calculation more explicitly. So we set y to be equal to 2. Then we get that 1 has to be equal to a times 2 plus 2 plus b times 2 minus 2. But this is 0. Which means that 1 has to be equal to 4a. Which means that a has to be equal to 1 over 4. Perfect. Now, another easy point for which is really easy to evaluate the expression is when y is equal to minus 2, because now the leftmost coefficient will be 0, and a will disappear from the equation, getting just an expression for b. We can just plug into y equal to minus 2, and we get the 1 has to be equal to a minus 2 plus 2 plus b times minus 2 minus 2. This guy is equal to 0. Therefore, we deduce that 1 has to be equal to minus 4b. That means that b has to be equal to minus 1 over 4. Great. So now we found our a and our b such that this equality holds. Okay? Let's write it down explicitly. We have that 1 over y minus 2 times y plus 2 is equal to a over y minus 2 plus b over y plus 2. That was the expression before. Exactly. And now we're just to set a equal to 1/4 and b equal to minus 1/4. So I can factor the 1/4, getting this is 1 over y minus 2 minus 1 over y plus 2. Perfect. Now, why I did all of this? Well, because actually what I need is the integral of the left-hand side in dy, which is going to be equal to the integral on the right-hand side, always in dy. And now the left-hand side is hard to compute, but the right-hand side instead I can express it easily in terms of logarithm. Let's go through this calculation really quickly. So the left-hand side, I have the integral of 1 over y minus 2 times y plus 2 dy. This is equal to 1 over 4, the integral of 1 over y minus 2 dy minus 1 over 4, the integral of 1 over y plus 2 dy. This is great, because now this is really easy to compute, because this one is just the log. This is 1/4 times the log of the modulus of y minus 2 minus 1/4 the log of the modulus of y plus 2. Perfect. So now what have we done? So we started imposing that these two integrals have to be equal. We found the right-hand side, and we use partial fraction expansion to obtain the second term. Now, to find y as a function of x, I have to equate left and right side, which means that after having factored the 1/4 between these two, I get that 1/4 times the log of the modulus of y minus 2 minus the log of the modulus of y plus 2 has to be equal to x plus c. And now what do I do? First, I can bring the 1/4 on the right hand side here. And then I can use the property of the log to write this difference as the log of the quotient between y minus 2 and y plus 2. So I get this is just the log of the modulus of y minus 2 over the modulus of y plus 2. And this one has to be equal to 4x plus, I should get 4c, but since c is just a random constant, I can just keep calling it c. Great. Now, since I want to find y as a function of x, I have to exponentiate both sides. So I take the exponential on the right and on the left of everything. And what do I get? The exponential of the log is just the argument of the log. So this is the modulus of y minus 2 divided by the modulus of y plus 2 equal to e to the 4x plus c. Now let's focus a little bit on the right hand side. Now I can use the property of the powers to rewrite this as e to the c times e to the 4x, right? And now since c is a constant, e to the c will be a constant too, so I can call it d. It's gonna be d times e to the 4x. Perfect. So now what I proved is that then now y minus 2 modulus over y plus 2 modulus has to be equal to d e to the 4x. Great. So now I have to somehow get rid of this modulus on the left hand side, and to do that I will actually leverage this constant. So these are random constants, so it can be positive or negative, and therefore I can just forget about the modulus on the left hand side because all the signs are going to be taken care from d, which means that this is actually equal to y minus 2 over y plus 2 equal to d e to the 4x. And now you have just to express y as a function of x. There are several ways of doing it. I'm gonna show you a trick that works all the time. So if you learn it, I think you're gonna really benefit from it. What I will do is the following. I will rewrite the left hand side in the following way. I will still keep the same denominator, y plus 2, and I'm gonna write the numerator as y minus 2, and then I'm gonna add 2 and subtract 2. And I want you to be stressed that this plus 2 and this minus 2 is exactly this plus 2, okay? So whatever I see up here, down here, I'm just gonna sum and subtract on the numerator. And why I do this? Because now I'm adding and subtracting 2, the same number, so this is 0, okay? So I didn't change anything in the expression, but it's gonna be helpful in a second. So the right hand side stays the same. It's gonna be d e to the 4x. And now what I'm gonna do, I'm gonna rewrite the numerator in the following way: y plus 2 minus the y over y plus 2 minus 4 over y plus 2 equal to d e to the 4x. So what I did, I picked up this plus 2 and this y, and I put it here, and I divided by y plus 2. And then I sum this minus 2, I get this minus 4 up there, and I still divide it by y plus 2. Why do we think this is smart? Because now this guy here on the left hand side is just equal to 1, because it's y plus 2 divided by y plus 2. So I get 1 minus 4 over y plus 2. This is equal to d e to the 4x. And now what I'm going to do, I'm going to bring these y's on the right hand side and these d on the left hand side. So I get 1 minus d e to the 4x equal to 4 divided by y plus 2. I'm gonna divide both sides by 4. So these two simplifies. So I get 1 minus d e to the 4x divided by 4. This is equal to 1 over y plus 2. Now I flip. So I flip numerator and denominator on both sides, getting that 4 over 1 minus d e to the 4x is equal to y plus 2. And now I just bring this plus 2 on the left hand side, and then I switch the order, getting that y is equal to 4 over 1 minus d e to the 4x minus 2. That's it, guys. So we went through all of it and we found this expression of y in terms of x, so we solved our differential equation. And that's all I have for you for today for this kind of exercise. If you like the video, just put a like, and if you want me to show more exercises like this, please leave a comment, and I see you in the next one. Bye bye.